In this video, we're going to talk about how to multiply and divide rational functions. This corresponds to section 2.6 of the Nelson 11 textbook. Okay, so first of all, let's recall a few things from the last lesson. What's a rational function? This is a function that is a polynomial divided by a polynomial. Okay. And we were talking last time about kind of how you'd find the domain or the restrictions. Okay. Main idea for restrictions is you can't divide by 0. Okay. Another key idea last time is to simplify some kind of rational function, you're going to make sure it's factored. Okay, you're going to factor any numerators and denominators. You're going to determine the restrictions at this point before you cancel anything out. And remember, the restrictions are when you're dividing by 0, so just check when you're dividing by 0. And the last thing you do is you cancel common factors. So we're going to use all that today, except here we have the additional step of having multiplied or divided these rational functions. Okay, let's take a look at example 1. Example 1, we're multiplying a rational function, so it says to simplify and state the restrictions. So first, you'll remember that when you multiply fractions, you can just multiply the top and the bottom, right? I'm going to write like this just to make that really, really clear. And then at this point, you're going to remember that you can take out some common factors, right? Let's start with the coefficients. So 6 and 8, you can definitely reduce that, right? That's going to be 3 and 4. 5 and 15, you can reduce that to 1 and 3. Now we can also start looking at some of the variables, right? Let's actually write it like this so it's a little bit easier to look at. Okay, here's our expression, and we want to cancel out the variables. Oops. So we know that we have 3 x's upstairs and 2 x's downstairs. That means you can take out 2 of them around the top and the bottom. That leaves 1 x upstairs. Same thing for y. You have 3 of them upstairs, 5 of them downstairs. You can take away 3 from both of those, so you're going to be left with 2 of them downstairs. Final simplified expression is 9x over 4y squared. But we're not done the question because it says to state the restrictions. So we're going to go back before we canceled anything, and we're going to say, what were the restrictions? So we're really looking here. Okay, so we know that looking here, x can't be 0, and y also can't be 0. Otherwise, you'd be divided by 0. Same comment here. X can't be 0, y can't be 0. So at the very end, the restrictions are that x can't be 0 and y can't be 0. That's the first example. Let's do the second one. Okay, so we have a slightly more involved one. You'll see some trinomials in there, difference of squares, whatever. So we're going to do exactly the same thing, but we're going to factor first. Let's factor x squared minus 4. That's the difference of squares, so that's x plus 2 times x minus 2. We're going to leave the denominator as it is, x plus 6 squared. And then we're multiplying by this next one. So we have x squared plus x squared plus 9x plus 18. If you factor that, you're going to get x plus 6 times x plus 3. And downstairs you have 2 times 2 minus x. Okay, we know we're just multiplying the top and the bottom, so I'm just going to save some writing and say that we're actually just multiplying all these factors. Okay, let's hunt for some common factors. So we know x plus 6 is slightly uncommon. Okay, you can take out one of them from the top and the bottom. And, well, at first glance, it looks like there's nothing there. But let's recall this trick that a minus b is really negative b plus a, which you can make look like negative of b minus a. So you'll notice that you can do this with x minus 2 and 2 minus x. So I'm going to change the fraction downstairs. Okay, that's going to be, I'm going to reorder it first. So you have 2 times x plus 6 times 2 minus x. And we're going to say 2 minus x is really negative of x minus 2. Remember this negative sign. Okay. Now that we've done that, we can cancel that x minus 2 out as well. Final answer, x plus 2, x plus 3 over negative 2x plus 6. Now remember that when you divide a positive by negative, you just get a negative. So it would be equally correct to put this negative out in front like this. Okay, that's the simplified expression. Now for the restrictions, because we still got to do that, we're going to look at this factored form before we cancel anything. Okay, so that is like right here. We're going to say x plus 6 cannot be equal to 0, and 2 minus x cannot be equal to 0, because otherwise you'll be dividing by 0. That tells us that x can't be equal to negative 6, and x can't be equal to 2. So when we're looking at our final simplified expression, we're going to say x can't be equal to negative 6, and x also can't be equal to 2. There's the final answer. Okay, let's do the next example. We have division now. So just to jog your memory on how dividing fractions works, generally we say that you keep the first fraction as it is. In this case, you keep the 1/4. You're going to change it to the multiplication, and then flip the second fraction. So 1/4 times 2/3. Then you do the same thing as your multiplication. Now I'm going to note here that I could actually simplify this, right? 2 and 4 have a common factor. The 2 to 4 is 1 to 2. Final answer, 1/6. Okay, so let's do one with an actual rational function. You'll notice there is a lot of unfactored business going on here. So the first step is you're going to factor everything. So 21p minus 3p squared has a common factor of 3p. So when you take that out, you're going to be left with 7, no, just 7 minus 3, no, 7 minus p is what you're left with. Downstairs, you have 16p plus 4p squared. You have a common factor of 4p, so you're left with 4 plus p. Then you're dividing by this thing. We have upstairs 14 minus 9p plus p squared. If you try to factor that, you're going to get 7 minus p times 2 minus p. Downstairs you have 12 plus 7p plus p squared. When you factor that, you're going to get 4 plus p and 3 plus p. At this point, remember, you're going to look for the restrictions. And you can't divide by 0. Now, In this case, what can't be 0? Well, the denominator just can't be 0. Okay. Same as we said before, so that means p can't be 0, p can't be -4, p can't be -4, that's a duplicate, and p can't be equal to -3. Now, one thing that people sometimes forget to check is if you're dividing by a fraction, you can't divide by 0. If this numerator is 0, then you'll be dividing by 0, and that's not good. So this also can't be 0. So p can't be equal to 7, and p also can't be equal to 2. Okay, so we have a whole bunch of restrictions now. We'll list them again at the end. So now let's actually do the algebra to simplify. So we're going to keep the first fraction the same. We're going to flip the second fraction, so that's 4 plus p, 3 plus p, over 7 minus p, 2 minus p. And then we're going to cancel common factors. So you'll notice p upstairs, p downstairs, that cancels out. 4 plus p, 4 plus p, that cancels out. 7 minus p and 7 minus p also cancels out. So final answer is 3 times 3 plus p over 4 times 2 minus p. And that's a good final answer. Some of your restrictions, p can't be equal to 0, -4, -3, 2, or 7. And that covers everything. Oh, I didn't finish this list. Okay, so first thing you do factor. Second thing you look for restrictions. Third thing you're going to turn it into a multiplication. And then you're going to cancel your common factors. That's it for this video. Happy studying.